Okay, it is time for a math lesson, and then I'm going to stop the live after that and come back on to do the other part because last time when I went an hour, it wouldn't save it to my phone. So I don't know what was the problem. So today I'm going to do functions, and it shouldn't take me that long. I'm going to do, explain what a function is, and then I'm going to talk specifically about linear functions. So, text message. Sorry, need a text back. This person. Oh, so cute. Oh. Okay, so I'm going to turn you around and we will go that way and we will do the math. And then I will talk to you guys, and I said I would go live with a couple of you, with 5. So I'll randomly pick that and go live with you, and you can ask questions and things about whatever you want to know about me. But for now, I'm going to do a math live so I can put another video on my YouTube channel and so I can help you guys out. So we're going to talk about functions. So let me do it here. It's a little too far away now. Okay, cool. Going to talk about functions. Okay. So what is a function? What is a function? So to determine the function, we need to know some vocabulary words. We need to know the word domain, and we need to know the word range. Domain is just the x-coordinates of, the domain is the x-coordinates or the range of x-coordinates. If it's a line, then it'd be obviously the range of it. Or if it's just dots, then you would just specifically name the x value, the x coordinates of the whole coordinate point. And then the range is the y coordinates. So in this case, like 2, 3, I'm going to just name some points here. So in this case, these points right here, the domain of this little series here would be 2, 4, and -8, because that's the x values. And then the range would be 3, 5, and 7, because that's the y values. So a function is where every input only has one output. Okay, so for every input, it only produces one output. That means the x values, the x coordinates cannot repeat. Because if I input the number 1 into an equation, I should only get one number, like 8. But sometimes you'll see like a coordinate point where it has like 1, 7. So that means when you plugged in 1, you can get either 8 or 7. So this would not be a function, okay? Because every input only should have one output, like one output. So if the x values repeat, then it's not a function. So for example, let's see if these are functions. You can tell me. So 3, 5, 4, 6, -2, 5. So you can say that this is a function because every input only has one output and the x values do not repeat. So this is a function. Let's do another one. -2, 10. So we have -2, 10, 6, 8, and -2, 9. In this case, this is not a function because we have the input of -2 will produce either a 10 or a 9. So it produces 2 outputs. So the x values do repeat, so it's not a function. So that's how you determine if it's a function, just by looking at points. Now looking at graphs, I'm going to draw a few things here. Now looking at graphs to determine if it's a function. you can do something what we call the vertical line test. So obviously if the x values do not repeat, if you can tell that the x values don't repeat, then it's a function. But what I do is, like, if you can draw a vertical line throughout this whole graph and it never goes through the function twice, then this is a function. So this one right here was a function. Yes. This one's a function. It's going to continue to go up to infinity this way and that way. So it will never cross 2. It might look like it does, but this actually continues to go out, out, out. Okay, so it never goes straight up. So this is actually a function too. In this case, if we draw straight lines, the vertical line test, we can see that it goes through the function more than once when we draw that one line. So this is actually not a function because the x values repeat. Okay, so now let's talk about linear functions. Linear functions have a constant rate of change, which means that they continue to either go up by a certain number or they continue to go down by a certain number. And there's another fancy name for constant rate of change. This fancy name for constant rate of change is called slope. So it's called the slope. And we can figure this out. We can figure out the slope by doing the change in y's over the change in x's. Your teacher might teach you the slope formula of y2 minus y1 over x2 minus x1, but I like to just write it as delta y over delta x, which just means the change in y's over the change in x's, okay? This one's a little easier to remember for me. So a change in y's over the change in x's. So let's figure out slope with 2 points. So for example, if I have -1, 2, and -5, 10, and I want to determine the slope, all I need to do is the change in y's, which basically is the difference in the y's. So I'm going to subtract 2 minus 10. And then I'm going to put it over the difference in the x's, the change in the x's. So -1 minus -5. Okay? Now, the only thing is you see I pulled the 2's first here, and it's from this coordinate point. You need to make sure the -1's first too, from the same coordinate point. You can't do 2 minus 10 and -5 minus -1. It has to be from the same point when you start, okay? So 2 minus 10 is -8, and then -1 minus -5 is, so remember our integer rules, those two things become a plus sign, so is 4. And so -8 divided by 4, we can still reduce it. We reduce it like a fraction, and our slope is -2, which means that we go down 2 and over 1 to the right, okay? If you don't remember integers, you can go and check out the video because I have a video over integers. Let's do another slope. One, 3, and 0, -9. So the change in y's, 3 and -9, so that'd be 3 minus -9 over the change in x's, 1 minus 0. So 3 minus -9 is 12, and then 12 over 1 minus 0 is just 1. Well, 12 over 1 is just 12. So basically what this is saying is we go up 12 and over 1 to the right for slope. So that's how you determine slope. Now we're going to talk about the 3 different ways you can write linear equations. Slope-intercept form, point-slope form, and standard form. The first one we're going to do is slope-intercept form, and I'm going to try to leave the title up here on my whiteboard. So slope-intercept form is what we call y equals mx plus b, and everything means something. So the y and the x are just coordinates that fall on the line, that fall on the function line. So, but the m is what we determine as the slope, and the b is the y-intercept. So the m is the slope and the b is the y-intercept. So to write in slope-intercept form, you need to know the slope and you need to know the y-intercept. okay? And then we can plug in any value for x and solve it, and then get the value for y, and we would know that point would be on that line. So for example, if I was given the slope was -4 and the y-intercept was 7, I can write this in slope-intercept form. All I do is plug in -4 for m and plug in 7 for b. So it'd be written as y equals -4x plus 7. And what this tells me is that my slope is -4 and my y-intercept is 7. So if I wanted to graph that, I'm going to write the equation up here. Y equals -4x plus 7. I can graph my y-intercept first. This means that it intersects the y-axis at 7. So here's my origin, go up 7. 1, 2, 3, 4, 5, 6, 7. And then my slope is -4. So it means I go down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then I can see where the line's going, and I can draw the line. Okay, so that's graphing it. So let's do another one. If I said the slope was 1/2 and the y-intercept was -3, so I plug in 1/2 for m and -3 for b. So y equals 1/2 x plus -3. There's actually a little easier way to write that, because when we have a double sign, we don't want to do that. Instead of writing plus a -3, you can actually just write it as 1/2 x just -3. Okay, you don't have to write plus a -3. You can just, you do the subtraction of that number. So -3. So that's how you would do it. So this tells me that my y-intercept is -3. And then I go up 1 and then over to the right 2 because of the slope. Up 1, over to the right 2. So let's graph that one. I'm not going to graph all of these, but we'll graph this one. 1/2 x minus 3. So -3, 1, 2, 3 on the y-axis. And then 1/2 means we go up 1 over right, because remember it's rise over run. Up 1 over 2 to the right. So rise over run, graph that, and there we have our graph. So that is slope-intercept form. Now let's talk about standard form. Standard form is ax plus by equals c. This is probably the form that you will see second most. So slope-intercept is the most popular, then standard form, and then point-slope form. But standard form, it tells you some things as well. It tells you the slope, it tells you x-intercept, and it tells you y-intercept. So the slope, how you find the slope is what you say -a over b. So a is the coefficient of x, and b is the coefficient of y, okay? So you would take the opposite of the coefficient of x over the coefficient of y to find the slope if it's in standard form. To find the x-intercept, and I'm just going to abbreviate it, you do c, ooh, that's a bad c. Okay, you do c over a. So it's whatever it equals over the coefficient of the x, because you're finding the x-intercept, so it's over the coefficient of the x. Makes sense. The y-intercept would be c over the coefficient of the y, c over b. So it tells you 3 things that you can use to graph the equation, because once you know these 3 things, you can graph it on the coordinate plane. So let me do one. If I say I'm going to give it to you in slope-intercept form, and we are going to rewrite it in standard form. So in standard form, if you notice, the x and the y are on the same, okay, are on the same side. In this case, the x is over here, the y is over here. So I need to bring that -2x over to this side. Well, I look at the operation in front of it because I'm taking the whole -2x. And I see subtraction, so I see I'm going to add 2x to both sides. -2x minus 2x is 0, because -2 plus 2 is 0. And then I just bring down that -18. Remember, I cannot drop that subtraction sign. And then over here, I can't combine those because they're unlike terms. So we have 2x plus y equals negative 18. And it's in standard form now. ax plus by equals c. So I'm going to rewrite that, and we're going to figure out the slope and everything. So 2x plus y equals negative 18. So it's in standard form now, so let's figure out the slope. Negative a over b. So the opposite of 2, which is negative 2, over b. What is the coefficient of y? It's not there, but we always know that it's understood as a 1. If it's not there, it's understood as a 1. So 1. So the slope, m stands for slope. Slope is negative 2 on this case. Let's find the x-intercept. The x-intercept is c over a. C over the coefficient of the x. So negative 18 over 2, and you reduce that just like a fraction, equals negative 9. So the x-intercept, where it intercepts on the x-axis, is going to be at negative 9. The y-intercept is c over b, or c over the coefficient that's in front of the y. So c is negative 18, and b is 1. Negative 18 over 1 is negative 18. So that y-intercept is negative 18. So if you had your coordinate grid, I could graph negative 9 for my x-intercept, so it's over here, and then it doesn't go all the way down, but I could graph negative 18, and actually wouldn't even need the slope. I could just connect those 2 points. So here again, x-intercept is negative 9, y-intercept is negative 18. Let's do one more. Okay, 8y equals 10 minus 2x. If I want to put it in standard form, I have to move this 2x over. So I look at what's in front of it, subtraction, so I'm going to add 2x to both sides. Those cancel each other out, just leaving me with a 10 over here. And then over here I have 2x plus 8y. So now it is in standard form. I'm going to erase this and rewrite it so it doesn't get a little confusion. 2x plus 8y equals 10. So now let's find the slope, the y-intercept, and the x-intercept. The slope is negative a over b. So the opposite of a would be negative 2 over b. The coefficient of y is 8. So negative 2 eighths. And we reduce that just like a fraction. It would become negative 1/4. The x-intercept is c over a. So c over the coefficient of the x-intercept, 10 over 2. And that becomes 5. So the x-intercept is 5. And then the y-intercept is c over b. So c over the coefficient in front of the y. And that actually reduces down to 5 over 4, or 1 1/4. And you would just graph that on the y-axis. So there you go. That is slope-intercept form. Now point-slope form. Point-slope form. This is our last form. Point-slope form. Y minus y1 equals m times x minus x1. So in this case, we are given a point and the slope, but that's why it's called point-slope form. So whatever is in the x1 is the x-coordinate, and whatever's in the y1 would be the y-coordinate of a point that's on that line. And then obviously m is still the slope, okay? M is still the slope. So if I gave you a slope of negative 3, and then I said it went through the point 3, 4, I could write this in point-slope form by just plugging this in for x1, plugging this in for y1, and then plugging this in for m. So point-slope form is y minus y1, and so that's the y value of the coordinate, so minus 4, equals the slope, which is negative 3, times x minus x1. So x minus the x value of the coordinate point, which is 3. And there we have it. We have point slope form. Okay, let's do another one. If I were to give you the slope is negative 3 and then the point that it goes through is 0, negative 8, we can do this again. So it's y minus y1, which is the y coordinate, so negative 8. Y minus negative 8 equals the slope, so negative 3 again, times x minus x1. So x minus x1, and x1 is 0. The x value is 0. Now I can actually simplify this even more, because if you notice I have the subtraction of the negative. Remember what I said? We can put those dashes together to make a plus sign. So instead of writing y minus negative 8, just write y plus 8. And then over here, x minus 0, well, a number minus 0 is just that number. So I'm just going to write negative 3x, because x minus 0 is just x, and then negative 3 times x is just negative 3x. So this is still in point slope form, but it's just simplified. Okay, now I'm going to take you through how to convert them to all three different forms, okay? So if I was given 2 points, the easiest form to write it in is actually point slope form if you're given 2 points, because you're already given half of it. You're already given a point. You can use either of them. It'll give you the same equation of the line. So what you want to do, we already have a point, so we need the slope. So we're going to use the slope formula that we learned at the very beginning. The change in y's, so 8 minus 10 over the change in x's, 0 minus negative 1. 8 minus 10 is negative 2, and 0 minus negative 1 is positive 1. So our slope is actually negative 2, okay? So our slope is negative 2. Now I'm going to write it in point slope form. I'm going to choose the point 0.8. So remember point slope form, y minus the y coordinate, which would be 8, equals the slope times x minus the x coordinate, which is 0. And we remember we can simplify that because x minus 0 is just x. So y minus 8 equals negative 2x. This is in point slope form. Now I can take this, y minus 8 equals negative 2x, and I can take it and I can put it in standard form, or I can take it and I can put it in slope-intercept form. I'm going to rewrite the problem. Y minus 8 equals negative 2x. That's in point slope form. And I'm going to put it in standard form. ax plus by equals c. So in this case, I need to move the x over here, but I need to move this 8 over here, okay? So, because we only want the x and the y's on one side. So I'm going to add 2x to both sides, because if you look at the opposite operation, that's subtraction, so add 2x to both sides. So now I have y plus 2x minus 8 equals 0, because negative 2 plus 2 is 0. But now I need to move this 8 over here, and I do that by adding 8 to both sides. So now I have, I'm going to switch the order here because it's ax plus by equals c, but it's just addition, so it doesn't really matter. So 2x plus y equals, those cancel each other out, and 0 plus 8 is 8. So now I have it written in standard form. So this was point slope form, y minus 8 equals negative 2x. This is standard form. And now that I have it in standard form, it's really easy to write in slope-intercept form. All you do is solve for y. So I take my 2x plus y equals 8, and I'm going to solve for y. So I just need to move this 2x over. So I'm going to subtract 2x from both sides, because if you look at what's in front of it, remember that's a positive 2x, so plus sign. So subtract 2x from both sides, and you get y is equal to negative 2x plus 8. Because it's a negative 2x, and then that's a positive 8, so you can say plus 8, because it's y equals mx plus b. Okay, you could have said 8 minus 2x. That's perfectly fine, but I like to put it in the order that the actual general formula is in. Y equals mx plus b. So y minus 8 equals negative 2x. 2x plus y equals 8. Y equals negative 2x plus 8. They're all the same function. They'll all graph the exact same line. But they're just all in 3 different forms. Okay, very good. So that is your little mini lesson on functions. I hope you enjoyed it. I will turn you around. Okay, I'm going to turn you around. I'm actually going to end this live, and then I'll come back on. So just give me like 2 seconds, okay? So I'm going to end this live, and then I'll come back on.